Hey Lambert.
Okay, I think we can start now. Maybe.
The video comes.
Okay. Good. Okay, I think we're live now, so we can start. Good morning and good afternoon, everyone who's joining us from different parts of the world. My name is Natalia Rodriguez, and I am the communications expert for UNITAC Hamburg. Today, I am welcoming you to the webinar, Building Tools for Sustainable Cities. This is a webinar organized by UNITAC Hamburg, and I'm going to give you shortly an overview of who we are as an organization. Today, we have a very exciting lineup of speakers where each of them are going to present a different digital tool specifically to support sustainable cities and to support urban planning. So first of all, I'm going to share with you the agenda of today, so you all know what are we going to talk about and have an overview of who is who. First, I'm going to give you a short introduction, as I mentioned you, about UNITAC, this partnership from UN Habitat, UN OICT, and the HafenCity University. We're going to start first with the tool of UN OICT. This is the City Resilience Tool, and it will be presented by Lambert Holdenhout. He's the Chief of Data Analytics and Innovation at UN OICT. Then we're going to speak with Sophie Naue and Wasim Brahim, and they will speak about BEAM. This is the building mapper tool developed by the team of UNITAC Hamburg. Sophie is an urban innovation specialist, and Wasim is a data scientist, both part of the UNITAC Hamburg team. We'll then go on and talk with Trivik and Leonardo. Trivik is assistant professor at Delft University of Technology and co-director of the Center for Urban Science Policy. Leonardo Nicoletti is a data visualization reporter at Bloomberg News, and he's a former researcher at Delft University of Technology. They will both give us an overview of the City Access Map. This is an open source web-based tool. And last but not least, we have Alexandra Knappe is a research assistant at the City Science Lab from the HafenCity University. And at the end of the presentation, we're going to have a short Q&A. We will have questions from each of the speakers, but if you also have a question, you can just type your question in the comment box in the live stream, and we will address the questions and give the questions to each of the speakers. So I'm going to be very short, but I wanted to give you a brief introduction of UNITAC Hamburg. UNITAC is a partnership, as I mentioned, between UN Habitat, the United Nations Office for Human Settlements, UN OICT, which is the United Nations Office for Information and Communication Technology, and the HafenCity University. We're based in Hamburg at the HafenCity district in the city. And the idea of, or like the reason why this partnership came together was to be an urban technology accelerator with the goal to improve the quality of life of cities. And what we do at UNITAC is to develop tools to support the acceleration of the Sustainable Development Goals, specifically the goal number 11, which is to make cities and human settlements inclusive, safe, resilient, and sustainable. UNITAC is part of the People-Centered Smart Cities flagship program from UN Habitat, because we use the people-centered approach when it comes to digital transformation and the development of smart city initiatives. At UNITAC Hamburg, we create open, transparent, and participatory digital governance approaches to reduce the digital divide. And we use mapping, spatial analysis, data visualization, and other tools to support data and evidence based planning for decision-making processes. These tools are based on data, and what we want to do is to think and create innovative ways to support and integrate an integrated urban planning and basic service delivery. This is something that we'll sort of exemplify in one of the tools that we're going to present you. We have a very interdisciplinary team because as a partnership, we have a team based here in Hamburg from the HafenCity University, but we also have a remote team from UN Habitat from different parts of the world. And we have our other core team from UN OICT who's based in New York, data scientists, urbanists, artists, economists, communication experts, all of us working together on the development of these tools. We have also a project advisory committee from each of the leading organizations. And basically the UNITAC offer is divided into three main sort of sections. First is strategy, so providing strategy and expertise on urban digital transformation to local and national governments. As I mentioned, we provide tools, approaches on public participation, spatial analysis, mapping, data visualization. But we also provide capacity and training for local governments on how to implement these smart city strategies and tools. In terms of strategy, for example, it can be a digital transformation assessment, it could be strategic advice for digital transformation, or it could be the development of specific strategies, policies, and frameworks for local governments. In terms of capacity, we provide peer-to-peer exchange, training for city leaders, and we also have a project which is called the Urban Academy with the aim to provide expertise to young urban planners and innovators in African cities. And our work is spread all over the world. We started with 3 pilot projects in Brazil, Itiquini, and Namibia. No, I'm sorry. In Brazil, Itiquini, Brazil, and Jordan, the Arab region. And we're developing 2 following up projects that are in development for Ukraine, Namibia, Tanzania, and Guadalajara. Our offices are based in New York, Hamburg, and Nairobi, where UN Habitat is based. If you want to connect with us, you can follow us on the social media. Then we can now go on and explore the different tools that we're going to present to you. So I'm going to give the floor to Lambert, who's going to present and talk about the city resilience tool. Lambert, the floor is yours.
Thank you, Natalia. Yeah. So you mentioned already that UNITAC will produce tools for everybody to use, and we intend to open source those tools as well. So we did a little experiment to start one of those tools, and it's focused on the idea that many cities in the world are experiencing stresses and shocks. So stresses being more sort of the ongoing difficulties that cities have to deal with, and it can be anything related to their geography or the climate. Some cities are in a place where it's constantly very hot, or some cities are have a lot of people coming into the city, this migration to the city, and it creates all these informal settlements around the city, and that's sort of a constant pressure that they have to deal with. So those are sort of the inherent challenges. And then there is shocks, things that just suddenly happen, things like earthquakes or floods, or might even be things like pandemics that happen to a city. And those stresses and shocks to a city are very much, they have a sort of lot of secondary effects and tertiary effects. If there is a flood, for instance, it might affect the power station, and then people lose power, which has other effects again, or the roads might be flooded, so there's no more transportation, which has implications for food delivery or etc. So there's all these compound effects. Trying to understand how that works in a city is very, very complex. Now, there's a technical tool, sort of type of database called Knowledge Graph that is very good at documenting those connections between different topics. And our idea was to use knowledge graphs to do a proof of concept to see if we can use knowledge graphs to map some of these complex relationships within a city. And we took floods as a particular challenge for cities to see what happens when a flood comes. How does it affect different parts of the infrastructure of the city, and how does it affect people? What is the reaction of people going to be to these floods, and what else is going to happen? And to map all of those dynamics in this knowledge graph. So we created a demo model of that, and we could ask very interesting questions. Now, I don't have the slides online, but probably Natalia, you can share later a link with the listeners, the viewers, to that explains some more of the project. And there is actually some suggestions there of how you could experiment yourself with this project. You need to have a knowledge graph. There's a type of database, so you need some technical knowledge to set that up. You can use the examples that we did. We give all the notebooks, the codes that we used for our experiments, and it demonstrates some of the questions that you can ask that are non-obvious questions, like how many people would be affected by if the water streams in this area, if the flood comes to this area, and what would be the effect if I create an extra drainage point here, or if I build a dam here. And the whole idea of these things in the end is to make urban planners, to give urban planners a tool to better prepare the city, to get the most effective mitigation actions. So to put it very concretely, if you have $1 million to spend, if you're the mayor of the city and you have $1 million to spend, how can you best spend them to save most lives or to prevent most damage to the city? That is the kind of question that we want city planners to be able to answer with the help of this tool. Now, it's not a turnkey tool, unfortunately, at this point, where you can just put it in, turn it on, and it will give you all the answers for your city. It's more like a proof of concept, an idea that we want people to experiment with and hopefully share with us their experiences. And maybe at some point in the future, we'll further develop it to become a more elaborate tool that is more of a turnkey solution. I don't know if we have an ability to take questions, or how
I don't know if any of the speakers have a question for Lambert about the usage of the model. As he mentioned, the idea of this model is that people can actually download the database and use the model and test the model themselves. I can definitely share the link about this story and about how these notebooks and this data can be sort of tested by the users. But if any of you have a question for Lambert about the city resilience tool, you can go ahead and ask. Okay, and if any person in the audience has a question, then you can also type it in the YouTube comment box, and then at the end we can also address each of the questions. Thanks a lot again, Lambert, for telling us about the city resilience tool.
Sure.
We'll now go ahead and talk about BEAM. BEAM is Building, Establisher, and Automated Mapper. This is a UNITAC tool developed during the last year, and we're sort of getting close to the final stage of this first part of the project. So I'm going to give the floor to Sophie and Wasim to tell us a little bit more about it.
Yeah, thank you, Natalia. I will quickly share my screen. Please give me a sign if you see it. I think now you can see it, but now it's in presentation mode. Yeah, Natalia already said I'm going to present one project we developed on behalf of UNITAC, where we're actually using AI to map informal settlements. It's called BEAM, or our tool is called BEAM, building and establishment automated mapper. And it's one project we developed for the city of eThekwini in South Africa, together with the Human Settlement Department as our partner, and as well the GIS Corporate. Actually, the main idea of this project and this tool was to develop a tool that uses machine learning to radically accelerate the detection of informal settlements on aerial images. So to really provide the city with a tool that they can use. I would provide you some background information first of all, because I don't know if you're aware of eThekwini and the situation in eThekwini. eThekwini is a city, Durban and eThekwini in South Africa, and you have a lot of informal settlements. Actually, you have more than 25% of the population in eThekwini living in informal settlements. And we have currently 15 on-the-ground land monitors for data collection. So 15 people on the floor to take track of informal settlement growth. So you can imagine that this fast-changing urban development, it's really difficult to capture this changes with 15 on-ground land monitors. So we had the initial situation that really manual marking of informal settlements is really time consuming, but in order to provide a pipeline of upgrading measures and to see where settlements are growing and to see how you can provide those settlements with basic services, you really need to have up-to-date records on informal settlements. So this is the initial situation of our project. And so we've had the objective to develop a tool to accelerate the detection. You can see it already on this image on the slide that we did that. The idea was detection on informal settlements due to AI to accelerate that and then improve urban basic service delivery. So what we did is we developed a tool, and it seems quite simple, but it's quite complex. What the tool does is actually it marks all pixels on an aerial image that are supposed to be part of a building. So you can see it in this image here that are supposed to be part of a building or a rooftop. So we developed a tool with an accuracy of 94%, sorry, that's quite high. And we are now able to produce up-to-date maps on informal settlements or on settlements. And those maps are actually GIS referentiated. So this is something that the city can use as a base map to do further planning. And just to give you an overall example, actually right now the city is able to map their informal settlements within 72 hours. So this is really accelerating a process that would otherwise take months to do with the whole project team. To get so far, I will not go into details because as well, Wasim is going to present the model and or the tool and show it to you, but we had to face some training challenges actually to get to achieve the accuracy we have right now. So in the beginning, when testing and developing this module started, the accuracy on the edges was sometimes lower. Sometimes the model marked overlapping structures as one. You can see this in this image with green buildings now, or the screen structures. And sometimes as well, large buses get picked up as a building, and buildings in the shade of trees were not picked up. So this is a lot of training. Wasim can explain it a little bit more into detail because he is doing it right now as well. And so it's not that you only can market it. But last but not least, what was really important for us was to develop this tool in a really user-friendly tool environment. So it's quite easy for the city to run the tool. It's only 4 steps, but we are going to see in detail when Vasil is going to show the tool. And we wanted to provide as well the city with a manual, so they have a step-by-step explanation on how to use the tool, how to install it, and that they can have it running on their own machine. So this is what we have done. And currently, before we go into the tool presentation, we are actually right now in the process of setting up a project advisory committee. So we want to ensure impact at community level. It's quite important for us to talk with community representatives, to involve local stakeholders so that they are aware of the existing of this module, that we can talk about as well challenges, opportunities, but as well about risks that are related to AI. So knowledge transfer is one next step that we are going to need to set up when we're setting up the community of practice, so that we can learn from each other and see how we can look for further use cases, not only to map informal settlements, but as well for further cities to upscale this project in South Africa. So, but I think now it's getting much more interesting because Vasim is going to show the tool, and here you can see on my screen already how it can look like. So I will just stop this presentation mode and hand directly over to Vasim.
Indeed, thank you so much, Sophie, for the introduction of Beam. And I will go now for a live demo. Let me share quickly my screen. Can you please confirm that you see my screen? Okay, great. All right. So as you said, Sophie, for Beam, we have the city of eThekwini as a pilot city, and for this demo, I'm using those 4 georeferenced images from the city of eThekwini. As you can see here, the buildings and the streets and so on. For this, I will directly start the tool, as you can see. So the tool, before a little bit going further. So as you can see, we have 4 steps to use the tool. The first step is about selecting the images, or technically speaking, the directory that we want to have the images from, the one we want to map. And the second is to select the model that we want to run, that we would like to run. That we like to run it on the images. Also, as you can see here, we have 2 models, UNET and HRNet. The difference is very, very small when it comes to accuracy. UNET has the accuracy of 94.5% at the moment, and HRNet has an accuracy of 94%. So here I will just keep it UNET as it is. And then I would select the output directory on where we would like to store the results of our prediction. And just speaking about the prediction is simply a marking for the pixels that our model detects and considers as buildings. It's as simple as that. Then I would run building detection. As you can see here, some details while the tool is running. It's giving always a status on how things are working there. So here it detected 4 images to work on. It calculates afterwards the estimation of time that it's going to need to finish the predictions. And as you can see here, it's the status of every image separately. So for instance, now the first one is in progress and the others are on hold. For time reasons, I already finished the running before we started the demo. And this is how it will look like when we finish the detection of the settlements. So as you can see here, all of them building detection finished, and this is the status. And you can see that for the 4 images, it only took 5 minutes and 1 second. So now comes I would say the important part, or I would call it more the exploring part. I would just drag and drop the images in QGIS. So this is how they look like originally. This is the buildings and so on from eThekwini. And now I will put on top of them the layer, or what we call, technically speaking, shape layer, where we can see the results of the predictions. So those are the files that have the predictions. And you can see already that, that the buildings are well detected, as you can see here. Let me zoom maybe a little bit more so that you can see in details. So you can see already that the model is working really perfect. It's not confusing cars and buildings. It's taking even buildings that are a little bit in the shadow. It's detecting that it's a shadow and it should take it. And also, as you can see, yes, exactly, that's a very good example. So as you can see here, if the building is not fully rooftop, it only detects the rooftop. Maybe let me do something also small here. Two things, basically. So first one, as you can see here, we can detect how many rooftops are in this particular area, which is an image. And we can also outline, and we can also outline, and we can also outline those rooftops. 1 second. Right. And we can also outline them here. So the other thing also, I would like to give some facts about the tool. So the tool processes the images super fast. It actually can process, or we say it can predict one image every 80 to 90 seconds, which means for the city of eThekwini that has around 3,200 aerial images, it can map all the city, as you said, Sophie, in a period from 70 to 75 hours. And that's very, very fast, of course, comparing to any manual work. I think that's it in short. If there are any questions, please feel free to ask them. I would be glad to answer them. And otherwise, back to you, Natalia. The floor is yours.
Thank you, Vasim and Noe and Sophie, I'm sorry. We do have some questions in the comment box, but I will then collect them and address them at the end of the session, because I would like to give now the floor to Leonardo and Trivik, so they can tell us a little bit about the city access now.
Thank you, Natalia. So, yeah, my name is Leonardo, and you know, I currently don't work anymore with Delft University of Technology, but in the past year, I collaborated very closely with them, and especially Trivik in the Center for Urban Science at Delft University of Technology. And yeah, so I will share my screen. So there you go. So yeah, today we'll hopefully give you a good overview of this new tool that we open sourced recently. It's called City Access Map, and it's about accessibility, especially active accessibility. So, you know, how far and how long does it take in any given point of a city to reach services on foot? And the strength of this tool is that it's available for any city in the world, really, that has more than 100,000 residents. And so let me give you a little bit of background as to why I built this tool and what the purpose behind this tool was. So recently we published a paper called Disadvantaged Communities Have Lower Access to Urban Infrastructure. In this paper, we investigated accessibility, so reachability to services on foot in different cities, in mostly Western cities, cities in the US and cities in Europe. And one of the main things that was missing from this paper is that, first, it wasn't very accessible to a broad audience. It was only accessible, as all papers are, to the scientific community and people who actually would go and read scientific papers. And the second thing that personally I felt was missing was that it was very Western centric. It was very centered around Western cities and how we can use data in Western cities to get better insights that then can be used for better planning decisions. And there's so many planning departments in the world that don't have the tools or the infrastructure or the resources or the capacity to actually do the same analysis and understand their city better and also make good planning decisions. So that's where I started thinking, how can we build something that is useful for any planning department, regardless of their resources and their capacity? And as we all know, data is harder to find when we look at the global scale, especially if we want to go to very, very granular insights as something like a city block, for example. So my question was, how can we build something that both covers every city in the world or close to every city in the world, and at the same time can still give complex insights into accessibility and insights as to which proportion of their residents have access to services in their city. And obviously, open sources of data are always limited and they can always be improved. But it turns out we have some good points to start. One is OpenStreetMap, which is now more than 85% complete. And the second one is the European Commission's Global Human Settlement Layer, which mapped population density for the whole world. And so let me just share my screen. So then using these two sources of data, I developed this tool that is freely accessible online. It's cityaccessmap.com. And it is basically a tool where you can search for any city in the world, and you will get insights into accessibility and distribution of accessibility across space, across the population of the city, and also access to different services. So you can use it to understand how access to, for example, public transportation is distributed, or healthcare, etc. So for example, let's put Hamburg, Germany here, which is where some of you are, I think. And we'll let the tool load. And so here you can see the first thing you see is basically the spatial distribution of accessibility. So the lighter color is basically lower time to reach services. And the darker color means that you need to walk longer to reach services. So what you see here is like an average across many different categories of services that we have identified. And on the left, you can also see that we cross-reference this with population density data. And so there are useful insights such as, for example, now here, the tool tells us that 84% of the urban population in Hamburg, Germany, has access to services within a 15-minute walk. Why 15 minutes? Because we've all heard the talk about the 15-minute city, and everybody's trying to achieve a 15-minute walkability in their city across the world. So that's the kind of benchmark that we put there. And you can also see something that is also useful, which is how Hamburg scores compared to other German cities. And you can see that Hamburg actually is not doing so great compared to Dortmund or Berlin, for example, which are also large cities, or also Munich, for example. And you can also expand this box, and you can do lots of little things. Like, for example, let's say you're only interested in public transportation. You can switch off all these services that you don't care about, and you click apply, and now you see that this percentage has changed. Now you see that 90% of the population has access to public transportation, and you also see how this is distributed on the map. And what this basically means is that actually a lot of people are living close to these lighter areas in the city of Hamburg. And you can do this for really any city in the world. Let's go to Rome, Italy, where I live currently. Yeah, now you see the same insights for Rome. We can reset it so that all the services are covered. And the other handy thing is that when you hover on the city, you can see that basically where the specific area that you're zoomed in on, like this city block, how it scores compared to the city average. So you see the city average is the gray line, and the city block is the yellow line. So yeah, that's really the main thing of this tool. And what really is useful with this tool is, of course, there are limitations because OpenStreetMap is not always complete for every city in the world. But the idea is that it is open source, people can contribute to it. As OpenStreetMap becomes more and more complete over the years, this tool will pick it up and continue to be more accurate. And it is free, so we don't have to rely on Google, for example, or other companies that own a lot of data on infrastructure and amenities. And so, for example, the idea here is that city departments in any city in the world, like, for example, here in Santiago, Chile, can use this tool to get at least initial insights as to how accessible their city is and what areas might be more strategic for them to plan, and for them to plan more services, and also which services to plan, because you can identify which services have less accessibility, etc. Yeah, and going into the details, how this tool was developed really isn't very, very complicated. It uses OpenStreetMap, like I mentioned before. It also uses the European Commission's Global Human Settlement Layer. So it is accurate up to 100 meters squared. So that's the size of a city block, pretty much. And we calculated accessibility using street networks from OpenStreetMap. So it is a network analysis using every node in the street network, and understanding how far that node is to a point of interest, which can be a school, like a dentist clinic, etc. All the points of interest that we've categorized into our 7 categories. And finally, we just converted the distances along the pedestrian network into minutes, so that it would be more understandable for city planners, for example, to understand. And yeah, there's lots of questions that can be answered here in the tool online. There's also a GitHub repository right here that also is open source. And I encourage people to contribute to it, make it more complete, make it more developed and accurate. And yeah, that's pretty much it for me today. And if you have any questions, then feel free to ask them. And if Trivik, you want to add anything, feel free to add.
I'm good. I think you gave an excellent overview of something that you've led and developed yourself. So great.
Thanks a lot, Leonardo. We do have some questions in the chat, but I will address it at the end. It was really interesting to know about the tool. I think I approached it because we saw like the response that the tool had, for example, on social media, and people already discovering it. So it's nice to explore it as well and see how where you live, because of what the tool shows versus the perception of that people have about the real sort of city. But I'm gonna give the floor now to Alex. Alex is a research assistant at the City Science Lab, and she's gonna talk about COSI, the cockpit of social infrastructure. The floor is yours, Alex.
Thank you. Thank you for the introduction. As Natalia said, I'm working on the project Cockpit for Social Infrastructure, short COSI. So COSI is a digital analysis and planning tool which bundles, visualize, and integrates statistical and geo-reference data to planners of social infrastructures. Mainly it's in use for the local government. COSI follows a three-step logic workflow from visualization of data through an analysis information to the simulation of the effects of population measures. To give you a feeling for this, I would like you to show COSI as quick and easy as possible. So wait a second. So this is COSI. First things first, it's in German, but I will translate. So we will choose a district. It's working, yeah. So we need a topic to choose, of course, and for that I will specialize my data. And we'll choose education and schools. So we will see the schools in this kind of district, and it's different schools. Yeah, to analyze, we will check a bit. And as abilities and analysis, like it's Erreichbarkeitsanalyse in German. So we will choose, of course, these schools, all of them, and we'll choose a walk. So we have like in minutes, I think I like to go for a 5-minute walk. So you see the layers now, hopefully you can see them. So the red zone is 5 minutes, 3, and the green one is 1 minute. So to see the demographic data, this is our last step. We will choose the population under 18 years. So maybe this is a kind of better look. So now you can see we have more than 5,000 of population. To see, I clicked on the eye and everything is there. You also can see this kind of tool if you want to see the years to know how many population are there. So I think that's already it. Wait a second, I will stop my screen. So what is particularly interesting about this process is that we are working together with the local government and a different project for civil participation called DPAS, because you can also take DPAS data and work with it. Due to the tight time frame, I will not show you this, but I'm also open to questions, of course. Thank you.
Thanks a lot, Alex. I am going ahead and address some of the questions that we have for some of the tools. We have a question from Francesco Tonarelli, and he's asking what type of images are required in terms of resolution, that's for beam, and if the tool work with satellite or drone images as well.
Thank you, Natalia. I can take that. At the moment, we need, again, like we need georeferenced data. The resolution that we use it for eThekwini is 72 dpi. And if possible with the drone images, yes, if they can provide this minimum of requirements. So georeferenced data and with 72 dpi's. And for the other question about satellite images, probably no, because of the resolution. According to my knowledge, it's very difficult to find satellite images with such good resolution, and the model would need relatively high resolution so that it can do the segmentation, which is marking those outlines of the building. Mm-hmm.
And we have another question, and it is, how does the tool detect between formal and informal settlements, if that's something that the tool can do? Can you let us know if there's like a difference between them and if the tool is capable of doing that?
I can jump in here. Actually, the tool is not in this moment differentiating between formal and informal. Because the tool is not smarter than we are, and it's a legal definition, no? So in a lot of cases, it's not a definition, okay, I just see a shape or I see a house and I can say, okay, this is an informal settlement. So what we can do in the future is, for example, the city of eThekwini knows which areas are formal and informal, so they can provide different layers of information, add those to the tool. But actually we can, or what we can do in a further step is we can train the model to recognize, for example, some materials of rooftops, but it's not always that this belongs to an informal building or an informal settlement. So this is still quite difficult.
Good. Leonardo has a question for Wasim, and it is, did you test the model on other cities in the same region or other regions of the world which have different landscapes, pixel colors, rooftops, etc.?
Thanks, Leonardo. Very valid question. Actually, we tested the tool on Dar es Salaam in Tanzania, but please remember that the model was trained for this city. It means that the model needs to know what kind of nature does the city have. So as you can see, as you have seen in the demo, the city of eThekwini was full of green trees and so on. So if you want to take this knowledge that you taught to the model and apply it somewhere else, the accuracy in the beginning would not be so high. But again, if you want to take it somewhere else and apply this knowledge, you need to learn the model, how it's working in another city. That's one. And two, also the nature of buildings. For eThekwini, for instance, there are so many buildings that has the shape of a circle, and in other countries or in other cities, this might not be the case. So in addition to the nature, it's this the nature of the buildings. The third thing is the material which makes the rooftop. It can be really different from a city to another. So long story short, it's not very easy to take just a model from a city to another, but training a model on a specific area or a specific use case is the key to make it work.
Thanks, Wasim. Can I ask you another question? A follow-up?
Sure, go ahead.
I was just wondering, I'm not sure if you mentioned this in the presentation, but what exactly is the method for training the model? Is it an unsupervised method, or did you have to identify a lot of the roofs yourself in order to train it?
Very good question, actually, yes. So for the training, we have a process for it. From methodology speaking, we use conceptual neural networks for this. And how does the training works? So we take an image, one of the images, and then we mark on it the buildings that we wanna detect in the end. After that, you keep training the model and correcting its mistakes. Like the model in the beginning would detect, if I remember when we were doing this, it was detecting, for instance, a pool as a rooftop, because it has, from image perspective, we know that it's a pool as a humans, but the model in the beginning, it sees the shape of a square, of a rectangle, it would think it's a building. So we had to train it so many iterations to make it learn that this is not a rooftop, but this is a pool, for instance. And also in other edge cases, as Sophie mentioned it, for instance, for the shadows, for the proximity also of the buildings, it might merge them, and we had to train it over and over to make it learn that those are two separate buildings and so on.
Thanks. Very interesting.
Vasim, people are asking if they can download the tool, if there's an option to be able to use them, or how can they sort of access it?
Actually, right now, we cannot provide a download to the tool. We will have an official launch in eThekwini end of November. And actually, as well as Vasim explained, no? So we need to see further, because you always need to build up a new model and train the tool further. So actually, if we would all now use this model for example, how we did it for Dar es Salaam, you don't get the accuracy that you need to really work with it further. But we are just in a pilot phase, and so we are looking forward to establish the model for other cities, and as well to provide knowledge to other cities, training and so on, as we have notebooks, how to train a module and so on.
Good. I don't know if any of you have another question for the speakers. I'm curious about, Leonardo, I wanted to know sort of like, how does the tool, like the city access map, compares to the perceived sort of experience from the users or from the residents of a city when they sort of use the tool, for example, especially for, you know, other countries in Europe when there's like more available data, for example, in other countries. If you have received any feedback on that so far.
I've only tested it honestly for myself for now in the cities that I've lived in, which is, you know, a good amount. I lived in Canada, in Vancouver, in Rome, Paris, the Netherlands, The Hague. So I would say that generally for those cities, I think it's pretty accurate, especially because, you know, we have to remember that the percentage that you see is really considering the population as well. It's not just the space, right, in the city. So in that sense, I think, you know, I think it is pretty accurate, but then obviously there are, you know, like cities in China, for example, in the tool that are picked up by OpenStreetMap, but it is well known that OpenStreetMap in China is very inaccurate. So I wouldn't trust the tool to, you know, make planning decisions in a city, a small city in China, for example. It really is up to the community now to test it. I've definitely got feedback already from people in Helsinki, people in Bogota. Actually, a lot of planners in Bogota have been discussing on social media good feedback, also some limitations that need to be improved. So yeah, it's really nothing more than what the data available is. But the good thing is that the methodology is strong, I think. And if someone did have a better source of amenities data, for example, let's say they have Google data that is more complete, right? Then they can take the repository on GitHub and they can run, it's like 4 Python scripts, and that's it. They calculate accessibility in their city if they really need that extra accuracy, right? But yeah, I think in general it's really about, you know, showing people in a very fast and user-friendly way the insights that they need, and then obviously they need to also go on the ground and double check that the tool is telling them things that aren't false.
And we have one last question for Leonardo and Trivik. Does it also work for peri-urban and rural areas, as the maps mostly reflect urban areas?
So it depends exactly what the what those areas are defined as. Because of data availability, we actually put the threshold at any area that has 100,000 inhabitants or more. Because below that, we did actually check with some small towns, and on top of the fact that, you know, accessibility in rural areas is not so important because lifestyles are different. Those areas have just different ways of living, and not every place in the world needs to have a 15-minute accessibility, right? So, you know, that's why we capped it at 100,000. So probably not. The answer is probably not. Mostly urban areas.
Good. I think we're like almost done with this hour for the webinar. So I want to thank you all for joining today. It was a really interesting discussion and presentations of the tools. We hope we can have more of these sort of webinars and invite more people to present some digital tool for cities. I also want to thank Mert Yilmaz, my colleague behind the scenes working on the technical part of the webinar. So until the next time, bye-bye and see you.
Thank
Thank
you.
you.
Thank you.
Bye.
Bye.
Thank you. Bye.